Hello, and welcome back to another set of IB Math Speedruns with me, Vince. So today we're going to be going through chapter 8.1, which is all about using integrals to find, I believe, areas and volumes. So let's jump right in. So I think I already touched a little bit about earlier on how we can use the integral to find the area under a curve, because just like we can use the derivative to get the gradient on a point, we can use the integral to find the area under a curve. So say we have a curve like this over here. If we're getting the integral between this point A and this point B, it will actually get this area under, well, this area here underneath the curve. And so we can extend that if we're getting the area sandwiched in between two curves. So for example, sorry about that. For example, we have two curves that look like this. If we get the integral from A to B of the difference between the two curves, then it will actually give us this area. So we have that the area between the graphs is equal to the difference between the integrals, or just the integral of the difference between the functions. And usually this is the absolute value of this, just so we're clear that the total area is positive and not negative. So with that being said, we can now jump into some questions. So I guess I will do the odd ones. So first one is find the area enclosed by the graphs of the two curves. So the first curve is y is equal to 1/2 x cubed plus 2x squared plus 2x minus 1/2. And the second one is y is equal to negative 1/2 plus 3x plus 2x squared minus 1/2 x cubed. So to get the region enclosed, we also need to find at which points do these curves intersect. So let's do that as well. We can simply set the y values to equal. So we get x cubed minus x is equal to 0. So we get x times x squared minus 1 is equal to 0. So this curve will intersect at 0, 1, and 2. So it's likely that we will have to get the integral between 0 to 1 and then the integral between 1 to 2. Yeah. So we have the, let's just integrate it first. So we get the integral of this first one minus the second one. So we have 1/2 x cubed plus 2x squared plus 2x minus 1/2 minus, so plus 1/2 x cubed minus 2x squared minus 3x plus 1/2 dx. So this is equal to the integral between x cubed minus x dx. So this will be equal to 1/4 x squared minus 1/4 x to the 4 minus 1/2 x squared. And so we need to evaluate this between negative 1 and 0, and 0 and 1. So between negative 1 and 0, this will be 1/4 times negative 1 to the 4 minus 1/2 times negative 1 squared. So this will equal 1/4 minus 1/2, and otherwise negative 1/4. But we have the absolute value, so this will equal 1/4. And similarly, if we do it above 0, we should also end up with 1/4. So I think we should get the area enclosed by the graph is equal to 1/2. 1/4 plus 1/4 is 1/2. So that should be the answer. Okay, Nice. On to the next problem. The next problem is find the region enclosed by y is equal to 3x minus x squared, and y is equal to 2x cubed minus x squared minus 5x. So to get the intersections, we set them equal to each other, so we get that 2x cubed minus 8x is equal to 0. So 2x times x squared minus 4 is equal to 0. So the intersections will be at negative 2, 0, and positive 2. So now let's get the integral, and we simply have to integrate the difference between the functions, which we already have. Which is, yeah, it's just 2x cubed minus 8x dx, since this is effectively the difference between the functions. So this will be equal to 1/2 x to the 4 minus 4x squared. So between negative 2 and 0, this will be 1/2 times 16 minus 4 times 4, which is equal to negative 8, so it's equal to 8. And likewise, on the other side, we get 1/2 times 16 minus 4 times 4 again. So this is also equal to negative 8. So we have the final answer is 8 plus 8, which is equal to 16. So the area bounded by these two curves is equal to 16. Okay, on to the next one. And the next one is y is equal to tangent of x over 2, and y is equal to 1. So get the area bounded by these two curves. These two curves will intersect at tan x over 2 minus 1 is equal to 0. So in other words, tangent of x over 2 equals 1. So x is equal to, well, this really will be an infinite amount. So because tan x over 2 will look like this, y equals 1. So I guess this area. Because the thing is, this is a weird question because it's not actually bounded by the curves. Because if you look at the graph, which is this, there's no region that's really enclosed by the curve. So, like, do they mean this? Like, if we get the intersection between pi over 2 and 0, or do they mean from where exactly is the region enclosed by the curves located? It's a bit confusing for me. So I'm gonna skip this question because I don't really understand what they're asking for. Because there's no region enclosed. Like, do they mean also with the x-axis? But that's too large. So yeah, let's move on to the next one for now. Sorry, I'm back. And so we were on the problem of y is equal to e to the 1 minus 2x minus 1. Y is equal to square root x, and x equals 4. So we need to find the area bounded by these parts. And so when I was trying to solve this problem, the only method I could think of to solve this was recursion, which we haven't covered. But anyways, the best way to solve this would really just be looking at a graph. So if we get Desmos out, leave that. What was that? So e to the 1 minus x minus 1. And the curve y is equal to square root x. So, and of course, x equals 4. So we need to find this curve, and so we just need this intersection as the lower bound, which is 0.476. So we can get the integral between 0.476 and 4 of e to the 1 minus x minus 1 minus x to the 1/2 dx. So if we integrate this, we get between 0.476 and 4 of negative e to the 1 minus x minus 2/3 x to the 1 x to the 3/2. So if we plug in these limits, we get negative e to the negative 3 minus 4 minus 2/3 times 8, so minus 16 over 3 plus, and you know what, if you want, you can solve for the exact values of each part for 0.476, but I'm just going to punch this into a calculator. Minus 4 minus 16 over 3 plus e to the 1 minus 0.476 plus 0.476 plus 2/3 times 0.476 to the power of 3 over 2. So I get an answer of 6.999, which is around equal to 7. So that is the answer. And then on to the final question. We have find the area of the finite region enclosed by the graph y equals cosine 2x and y equals ln x minus 1. So to get the intersection between these 2 points, again, it's going to be recursion. So if we plot this into Desmos, we have cosine 2x and the natural logarithm of x minus 1. So as you can see, we have 3 intersections over here. So let's just put them up again, 1, 2, 3, and so now we can just integrate. So we have cosine 2x minus ln x minus 1. This is in brackets. Dx, and so the first part, cosine 2x, is the relatively easy part. It's simply going to be 1/2 sine 2x. But the second part is a bit harder. We need to do integration by parts, so we can do that over here. Because if we have the integral of ln x minus 1, we need to do u is equal to ln of x minus 1, so we can have u prime is equal to 1 over x minus 1, v prime is equal to 1, and v is equal to x. So this is equal to x ln x minus 1 minus the integral of x over x minus 1, which we can split this into 1 minus 1 over x minus 1. So 1 plus 1 over x minus 1, which of course we can easily integrate into x minus ln x minus 1. Yeah, so now we can punch this back into the original one. So we have the 1/2 sine 2x minus, and then this is going to be x minus 1 of ln x minus 1 plus x, I believe. So if we do this for 3 values of 1.392, 2.601, and 3.396, well, we get values of 0.5 sine 2 times 1.392 minus 1.392 minus 1 times ln 1.392 minus 1 plus 1.392. So this is equal to around 1.934. Next, for 2.601, we have 0.5 sine 2 times 2.601 minus 2.601 minus 1 times ln 2.601 minus 1 plus 2.601. So we get, this is equal to 1.406. And then finally, for 3.396, we have 0.5 sine 2 times 3.396 minus 3.396 minus 1, ln 3.396 minus 1 plus 3.396. So this is equal to around 1.546. So if we get the differences between these limits, we will get this is 0.14, this is around 34 minus 1.406, 0 and 0.528. So if we add these two together, we get something like 0.668. So this is the area under the curve. So yeah, that was all for the speedrun. I hope you enjoyed, and I hope to see you in the next one.